Okay, so this is a question. Okay, now for this question, number 5 is similar to question number 4. Okay, so the question given that we have a two group in year 1 and year 2, the sample size also different. Now, for the year 1, the sample size is 100, and year 2, the sample size is 200, and given the different average claim size. So the average claim size for year 1, that's 10,000, which is equals to the summation all the observation divided by N1. That is summation of X divided by N1. And for the second group in year 2, given the average size is 12,500, which is equals to the summation of all the observation in the year 2 divided by the sample size, that is 200. Okay, so that is summation X divided by N2. So this question is the claim size actually follow the Pareto with this parameter. Alpha is known, data is unknown. Okay, so in this year 3, we have to estimate the parameter. Okay, this data is varies during for the year 1, year 2, and year 3. So we have to find what is the value of this parameter in year 3. So this method is like this question is similar to question number 4. So we have to find all the claim size in year 3. So based on year 3, then we can solve the problem under inflation 10% per year. Okay, so here we go.
Solution for number 5. Let xi be the claim random variable such that xi is Pareto distributed parameters, alpha is 3, and theta I corresponding to year I for I is 1, 2, and 3. Since the claims inflated at 10% annually, therefore, x2 is equals to 1.1 x1, and x3 is affected 10% as well. That's become 1.1 from the x2 in year 2. Then we have the following chart. In year 1, is given the 100 data, that is from x1 to x100. So in year 2, the x2 is equals to 1.1 multiply this data x1. And for this data x100, similarly we will have a 1.1 multiply this x100. We also given that we have 200 data in year 2. So namely, we have x101 until x300. So altogether we have 200 data, and here we have 100 data. So in year 3, this will be 1.1 multiply the x2 data, so we will have 1.1 multiply 1.1 again, that's become 1.1 square x1. And similarly for this, it's become 1.1 square and multiply the data of x100. And here will be 1.1 multiply this data, that is become 1.1 times 101. And the last one will be 1.1 times x300. Where given that the summation of this xj, when j is 1 to 100 and divided by 100, which is the average that is given by the questions, that's 10,000. For this average, the summation for the xj, when the j take from 101 to 300 and divided by 200, which is the sample size, and which is equals to 12,500. Now, in year 3, we consider X3 is Pareto distributed with the parameters alpha is 3 and the estimate of theta 3. Then, from table C, we will have the first flow moment, which is equals to the theta 3 divided by alpha minus 1, which is theta 3 divided by 2. But the sample moment will give first flow moment, which is equals to the average of the data from the year 3. So we sum up all this data divided by 300. And so this will be equal to 1 over 300. Sum up 1.1 square x1 plus until 1.1 square x100 and plus 1.1 x101 plus until 1.1 x300. And this is equals to the estimate of theta 3 divided by 2, that is here. And we can simplify this by factorize 1.1 square, sum up all the data from x1 until x100. And here again we factorize 1.1 and sum up all the data from 101 to the data of x300. Therefore, data 3, which is equals to 1 divided by 150, and this is a 1.1 square summation of xj, where j is taken from 1 to 100, and plus 1.1 multiply the summation of xj, where j take from 101 to 300. So this is equals to 1.1 square, and this value is given, which is equals to 10,000 times 100. So we will have 10,000 times 100 and plus 1.1 and multiply this result, which is equal to 12,500 times 200. And so we found the result, which is 13,200.
Okay, so for this problem, as I said, that you need to get the third year data for the claims after the 10% inflation. So once you have the data in the year 3, then you can use the information from the question. That is here you have to take note that the average is 10,000, not the summation. Some students, they put a summation of x for the year 1 is 10,000. That's wrong. You need to take the summation divide by the n, which is equal to 10,000. Similarly, for year 2, also the same. That summation of the x divided by the N2, which is 12,500. Okay, so after that, you can go to the method of moment, take the formula from table C under Pareto. So you will have this first flow moment. Okay, and then after that, we try to focus on year 3, and then the expected value of this, of course, is all the x value from the year 3, right here. So after that, you factorize into group of year 1 and year 2, then you can see something. Okay, so the first group, this is a summation, right? So you substitute, right? So remember the summation, this summation is equal to 10,000 multiplied the n. Some students, they put a summation which is equal to 10,000, that's wrong. Okay, because the average is given is 10,000. So therefore you have to take the average multiply the sample size. Okay, so this problem solved if you really follow the procedure. Okay, so this is question number 5 that we missed up Tuesday. So now we move to question number 7. 6 we have done. Okay, let's go to 7.
Number 7. You are given the following. Losses follow a Pareto distribution with parameters theta and alpha is 3. So we let this x be the loss random variable, and which is Pareto distributed with these parameters. 300 losses have been observed. So this is sample size, which is n. Determine in terms of theta the variance of estimate of theta by method of moments estimator of theta. So by using the method of moment, we try to find the variance of this estimate of theta in terms of theta. Solution for number 7. Let x be the loss random variable such that x is Pareto distributed with the parameters alpha is 3 and theta, which is unknown. Then from table C, we will have the first row moment and the second row moment, which is in terms of theta. Now from the sample moment, given that the sample size, the n which is 300, then the first row moment, which is equals to the summation of xi, where I is from 1 to 300 and divided by 300. Now since this is equals to this result, so this will give theta over 2, which is equals to this. That's the summation of xi from 1 to 300 and divided by 300. So therefore, the estimate of theta, which is equals to 150, multiply the summation of this random variable xi from 1 to 300. Hence, the variance of this estimate of theta, which is equals to the variance of this result we have found, and this constant you can bring out, that has become 1 over 150 square, and the variance of this summation that's become x1, x2 plus until x300, and this is equals to variance of x1 plus variance of x2 plus variance of x300. And since all the random variable x are identical, therefore they have the same common variance. So the result of this becomes 300 of variance of x, and which is divided by 150 squared. So simplify this become 1 over 75, and this will give me the second row moment minus the first row moment square. And this is equals to the second row moment. We have found that which is a theta square, and the first row moment which is half theta square. So we will get the variance of this estimate of theta, which is equals to theta square divided by 100.
Okay, now for this problem is quite mathematical, like question number 6. Okay, so this problem you have to take note. At first, you have to take the first row moment, second row moment under Pareto. Okay, then because this question asks to find the variance of theta in terms of theta, so you have to get the information from your first row moment that your theta will be equals to 1 over 150 and multiply the summation of x. So once you have this connection, now take note here, we will use the capital X for the random variable instead of the value for this problem. So the both side you take variance, okay, and since this is a constant, you would put outside that this become constant square, okay, and all these x are random variable x are identical, therefore they share a common variance, and we call as variance of x. That means altogether we have 300 variance of x, okay. So you simplify, you will have this, and then after that you convert to this first row moment and second row moment. So substitute the in terms of data from above. Okay, so this problem solved. Okay, so this is the answer for the variance data in terms of this. So the whole working here, you can see that is quite mathematical. That is based on the method of moment. Okay, so you will learn something from the question 6 and 7. Okay, that is based on the variance. Okay, so any questions? We have done 7 now. So I move to question number 8.
Question number 8. You are given the following sample of 5 claims, that is this data. You fit a Pareto distribution using the method of moments. Determine the 95th percentile of the fitted distribution. So let x be the claim random variables for these 5 data, where x is Pareto distributed with the parameters alpha and theta. So by using the method of moments, we have to determine the 95th percentile of this fitted distribution. That is, our aim is to find what is this 95th percentile. So in order to solve this problem, we have to calculate the first row moment and also the second row moment from this sample, and compare the first row moment and the second row moment from the table C under this Pareto distribution. Then we can estimate the parameters of alpha and theta and this problem solved. Solution for number 8. Let x be the Klein random variable such that x is Pareto distributed with these parameters alpha and theta. Then from table C, we will get the first row moment and the second row moment in terms of theta and alpha. And from the sample moment, we will have the first row moment, which is equals to sum up all the theta and divided by the number of sample size, which is 5. So we will have 105 multiply 4 plus 5 plus 21 plus 99 and plus 421, which is equals to 110. So similarly, the second row moment, which is equals to 4 square plus 5 square plus 21 square and plus 99 square plus 421 square and divided by 5, and we will have 37504.8. So therefore, this first row moment will be equal to this, and the second row moment will be equal to this. Therefore, we will have the following. This theta divided by alpha minus 1, which is equal to 110, and we name this as the first equation, and this will be equal to this. Therefore, 2 theta squared divided by alpha minus 1 divided by alpha minus 2, which is equal to 37504.8, and this is the second equation. And now we try to solve the first and second equation. We will have the estimate of alpha, which is equals to 3.81889, and the estimate of this theta is equals to 310.0782. Now, at the 95th percentile, we will have the following. That is the CDF at the 95th percentile, which is equals to 0.95. So this can be explained by a diagram. That is at this 95th percentile, and the probability of this CDF is 0.95. So based on the Pareto distribution, and this is equals to 1 minus 310.0782 and divided by this x value, that is the 95th percentile, and plus 310.0782, and to the power of 3.1889, which is equals to 0.95. So we solve this equation, then we will have this 95th percentile, which is equals to 369.366.
Okay, so this question is a combination of the method of moment and also the percentile matching. So we have to find the 95th percentile. So based on the method of moment here, so you have to find the first and the second row moment, okay, in terms of data, and from this calculation we can calculate. After that, you just try to substitute the value into the first and second row moment, okay. Then after that, you solve the equation, you will get the value of alpha and theta. So our first method here, using the method of moment, just to estimate the value of parameters. Then we go to the second stage, that is based on the percentile. So the 95th percentile, I will explain to you what is means by the percentile. The 91st percentile actually is a value. if our x is a claim random variable, so this 95th percentile that is denoted as a pi 0.05, pi 0.95 is an x value. It's a claim. It's a money. Okay, so we want to find how much it is. Okay, how much is this the claims? Okay, that is represented by this pi 0.95. So we use the CDF because of this area. Okay, under the graph before pi 0.95, the percentage is 0.95. So from this CDF, you can go to the formula in table C, look at the Pareto, then substitute the parameters value, then you will get this X value. Okay, so the X value actually is about $369. Okay, so this is a claim size. Okay, that we have 95% where the claim is less or equals to 369. Okay, so you have to know what it means by 95th percentile. Many students still dreaming, don't know what is this. This is not percentage. This is an X value. It's a claim. It's a claim. Okay, so we move to question number 9.
Number 9. A sample from an exponential distribution uses these 5 data. Percentile matching at the 40th percentile is used to estimate the parameter. Determine the estimate of the mean. So let X exponential distributed with the parameter data. Our aim is to find what is the estimate of this mean, that is the data. So in order to solve this problem, we need to find what is the 40th percentile. And from here, we can apply to the CDF of this exponential and this problem solved. Solution for number 9. Let x be the random variable of the 5 observations such that x is exponentially distributed with the parameter data, where when the non-descending data is given as follows. At 40th percentile, that is the probability is 0.4. Now, since the sample size is 5, then 0.4 multiply n plus 1 must be bounded between m and m plus 1. And this will give 2.4, which is bounded between m and m plus 1. Therefore, m is 2. That corresponds to x2, which is 300, and x3, which is 1000. Thus, the 40th percentile, which is given by the estimate of this pi 0.4, and which is equals to this formula. So we will have 2 plus 1 minus 0.4 and multiply n plus 1, and multiply the x2, that is 300, and plus the 0.4 multiply n plus 1 and minus 2, and multiply x3, that is 1000, So this will give 580. Therefore, the CDF at this 40th percentile, which is equals to 0.4. So by taking the formula from table C under exponential distribution, so we will have 1 minus exponential to the power of negative 580 divided by theta, which is 0.4. So we solve this equation, then the estimate of theta, which is 1135.42. Thus, the mean of this exponential x random variable, which is equals to this estimate of theta, and which is equals to 1135.42.
Okay, do you understand? Now, for number 9, quite simple. Based on this 5 observation here, you need to calculate the m. Okay, so I believe you know how to calculate the m. Okay, so once you have m value, then you can calculate the corresponding value that is x2 and x3. So we apply to the formula, then you can calculate the 40th percentile, right? So just apply the formula, you will get it. Then after that, this is the x value. Remember I told you the 40th percentile is also an x value. That is a 580. Okay, so we substitute this x value inside to the CDF. Okay, you can get the form in table C. Then you can calculate the data parameter. Quite straightforward, these questions. Okay, so we go to number 10.
Number 10. For a complete study of 5 lives, you are given the following. First, death occurs at times at this data. Second, the underlying survival distribution is given by these equations for t is greater or equal to 0. Using percentile matching at the median, calculate the estimate of this parameter lambda. Our aim is to estimate this parameter lambda using the percentile matching at the median. So this median, in other words, is the 50th percentile. So we let t as the time random variable for this 5 non-descending data. So since we do not know what is this distribution of t, so we have to base on this survival function to estimate this median, that is the 50th percentile. Then this problem solved. Solution for number 10. Let t be the time random variable of the 5 observations such that the survival at t is given by this formula for t is greater or equal to 0, where the 5 non-descending data is given by this. At median, that is at 50th percentile, whose probability is 0.5. Since the sample size is 5, then the following equalities must hold. That is, the probability multiplied n plus 1 must lies between m and m plus 1. So this is equals to 3, and which is bounded in between m and m plus 1. So therefore, we choose m is 3, and which is corresponding to the third data, that is T3, which is 3, and the fourth theta T4, which is 5. Thus, the 50th percentile, that is median. So which is given by the estimate of this 50th percentile, and this is equals to this formula. And so we have 3 plus 1 minus P times n plus 1 times T3, which is 3, and plus P times n plus 1 and minus 3 and times the fourth theta, which is 5, and this is equals to 3. Therefore, the survival at this median, that is the estimate of this 50th percentile, which is equals to 0.5. And this will give 4 to the power of negative lambda at this value, which is 3, and equals to 0.5. So we solve this equation, then we can estimate this lambda, which is equals to 1/6.
Okay, so this question also quite obvious. From this inequality, you have to calculate the m, then you will get these two values of this observation, T3 and T4. Okay, and next, of course, you know what to do. That is just substitute into the formula. You will get this 50 percentile, because this is the median, right? Okay, median, at this median here, the survival is 50%. So we substitute this x value, that is 3, inside to the formula is given by the question. So you will get the parameter of lambda. Okay, so this is quite obvious. Now, please take attendance, class. I have created the code. Okay, so this is our attendance. Please check in now.